So previously we've used the identities for sum and difference of an angle to solve some problems. Now we're actually going to use it to do a proof. And this may look familiar to you. We've done something like this before using a graph to show that sine of pi over 2 minus x equals cosine. But a graph gives us an idea. It's not really a complete proof yet. So this is a formal proof to be absolutely certain. And to make use of, to do this proof, we're going to have to make use, in this case, of the sign of a difference rule. Okay, so that's what I am going to apply. So we're going to start here with our left hand side. Sine of pi over 2 minus x. This is given. And then we apply the sign of a difference here. So in this case, the first number x is really pi over 2. And the second number is really x. Okay, so it's a little bit confusing with the variable names, but you just think of it as some number, one angle, minus another angle, okay, instead of thinking of it as x and y. So this is really sine, this is step 2, this is sine of pi over 2 times cosine of x plus cosine of pi over 2 times sine of x. Okay. And this is sine of difference. Oops, this is, I made a slight mistake here. This should be a minus sign instead of a plus sign. So sine of pi over 2 cosine of x minus cosine of pi over 2 sine of x. Okay, that's what the sign of a difference means, not the sign of a sum. And now the next step, fairly straightforward. So sine of pi over 2, well, that's just 1. Cosine x is still cosine x minus cosine of pi over 2 is 0 times sine of x. Okay. So this, the reason here is just ratios for sine of pi over 2, cosine of pi over 2. So now we just simplify. This is all gone, and we just have cosine. Whoops. Cosine of x, which is the right hand side that we set out to prove. So there you have it. So now we can actually prove all of these co-function identities using the sign of a sum or sign of a difference.